Alright, is this working? Alright, is this working? Alright, is this working? Alright, I'm just gonna get straight to it. I'm trying to learn JavaScript and I'm gonna try to make a game. We'll see how that turns out. I'm also following a book which is called Pro HTML5 Games, and it has a couple of about 12 chapters with at least 3 projects, I think, which ranges from making Angry Birds clone all the way up to making a RTS game, and there is also multiplayer and well, a lot of in between stuff like pathfinding and graphics handling and stuff like that. Obviously, I need graphics, so you know that's gonna be what I'm gonna try out first. So I got this basic HTML document here with a canvas in it, and we're also going to put code in this, and this is what it looks like over here. And any changes I make, I'll try to reload as quickly as possible and have a look at it in the browser here. So at the moment, we'll just try to push stuff to the canvas, basically. And for that purpose, I've already made a variable which I called canvas, which gets the it gets the element, HTML element here, canvas element, and saves it to a variable in the JavaScript section. So what we need now is to get the context, the graphical context, which has a couple of parallels in Java, but this is not Java, so I'm literally knee deep in something I don't know anything about. So yeah, we're gonna pull out the context part, which is pretty simple, I think. Var graphical context, and then canvas dot get context, and then we're gonna get the 2D one like this, and then that should be it. Then we have a graphical context. Usually people would uh, try to write this as just CTX, for example, or G2D, stuff like that. But I'm gonna write my code as readable as possible for for viewer's sake, I guess. So again, graphical context. So it might be a bit typey, but I hope this will be readable and good. If this is, I can also turn up the resolution now that I think of it, so or the font, so that people will be able to read it. I think I can do it at least. Let's have a look. This is all maybe settings. Tools, preferences, font, larger. Okay, so now it's nice and overwhelming. So chat should be enabled if you guys have comments, by the way. All 0 of you. Let's keep moving. Let's see, let's just load in canvas and then load in graphics context like this. Okay, so with this variable we should be able to actually do some stuff. Let's draw a rectangle, I guess. Graphical context dot fill rectangle. Let's let's try that, I guess. 200, 200, 200, 200. No, obviously this one works, so that would make a really small rectangle, I guess. Like this. Save and try. Nothing. So I guess I missed something. Yeah, I must have missed something. Let's see. Just have a look at the console just to make sure that I haven't. Yeah, it's not a function, so yeah, and it's true, it's not a function. It shouldn't have angle in it for some reason, because rectangles don't have angles, you know. Save and run again, and there we go. Rectangle, we have one. Okay, so we have a rectangle, I guess. Let's move on to something else. Oh, one sec. I have to go away a bit, a few minutes, and I'll be back again. Alright, I'm back. I have two kids. They sleep downstairs right now, and one of them suddenly woke up, so I had to tend them a bit, of course. And yeah, let's get back to business. Here we got okay, so here we got our code, which makes a rectangle, and that's a start, I guess. You can make a lot with just basic geometry, really. But you know, let's try to add something more. So let's have a look at the book again and make some stuff. Yeah, okay, let's draw a path. So graphical context dot begin path like this, and then let's just copy paste this because we're going to type that a lot. If not, move to, and then let's say 20 300, something like that. Yeah, I'm just trying to orient my head around the whole scheme of coordinates in a system like this. Basically, you have something like this, where x counts downwards, or y counts downwards. I mean, and x counts to your right. So a lot of like grade school math goes kind of the opposite way, where a positive y would go upwards, and this is not the case in most of computer graphics. The 0 point is up in the corner of your application or your view screen, so it's over here, right here. And the first number you feed it with is the x value, which I put to 20, so it should put it somewhere around here. And then positive value of 300, which should put it somewhere down here, I guess. I mean, this one is at 200 already, so it might be that I shoot it over the screen because this is 480. Actually, let's just make a rectangle in the same area first. Let's just comment out these things and then move this one to 20, 300. And these are the dimensions, by the way, so height and width, and that should create like that should make just a square box, basically. Save and then refresh, and yeah, so the point is here, apparently, and then it just fills out a direction in each way and fills out, well, draws a complete path around it and then fills it, because this is a fill rectangle function. Okay, so we know this already, and we can just hit Control Z until we restore the box. We can hit Control S, save, and the rectangle should be back in its original position, and the whole begin path and move to hasn't done anything yet because we're not actually drawing anything. So we could start by actually sending a line somewhere. So again, graphical context and line 2, and then send it somewhere. Let's send it to 120 and just make a on 300. So this will create a line, I hope. Let's just hope that works. We'll see. Let's save and reload. And nada, so I'm probably forgetting something. yeah, probably we have to close the path again from what I'm reading right now. So, you know, as you might get, the impression might be there that I'm not like really knowledgeable about this, and it's kind of true actually. I mean, familiar somewhat with the syntax of JavaScript and some basic functionality, but I'm mostly a Java kind of guy, and this is kind of new to me, but I want to explore it, and you know, I don't want to be a wizard in that, or like present myself as a wizard in this, and so I'm just gonna do some stuff, and we'll see how it goes. You may laugh at my ignorance, and I welcome you to it because I'm gonna have fun with this. So, moving on, let's try to just close the path, I guess. And this should hopefully do something. Still nothing. So, yeah, that was not the one. Let's try stroke. There we go. Now we have a line. So now we could just duplicate this one and just make some changes to it. And that should give us a more of a path kind of thing going on. So we could try moving this one to the next. It will say, I mean, this will draw the first line. Okay, so the second one should start a new line from the point where the first line ends, and to wherever the next coordinate I feed it goes to. So this one draws the second line. Okay. Let's try to move it in the Y direction a bit. Let's move it towards the bottom of the screen a bit. Quick change. Added 20 pixels to it, and hopefully this should make a alteration. Yeah, there we go. Small box change, or a small line there. Let's have a third line. Just change the context of the comment as well, so that it's correct. Let's make this one trace back a bit. Let's have it to 260 and update. Oh yeah, Y direction. Stupid me. So that's not what I wanted. Let's have it back to 320 again, and let's see how much 20 or change in 20 pixels will do on the X line. Okay, so we can add it, put it to 80. Let's say 80. See how much that is. Okay, that was. Let's put it to 85. Did I save and did I update? Yeah, probably. Okay, let's move on. A new line. And this one should be further down, so let's say 380, not 3000, that would be a bit too much. So yeah, there we go. More changes. Like this. Actually, let's try to move this one a bit further down. So 400. Not 4000, 400. Okay, there we go. And we'll continue the line. Chat is encouraging me to do this naked, but I have morals, so no. Let's move it to 70. Yeah, we're getting something here. 65. For those who might have guessed it, I'm trying to make the letter T now because complex shapes is fun, I guess. Or, well, it's not really complex, but whatever. Let's do it. Draws the fifth line. This is the sixth line, so This one should go up again to 320, like this, and then an update. And there we go. Let's actually go ahead and move this one to 25, I think. This should change. Ah, okay, that was a bit too little. Let's move to 30. Did I save? No. There we go. There we go. Okay, next line. This is the 7th line. And we're gonna have this one yeah, so this one should move to I guess 30 instead of 65. My spatial awareness is kind of crap, so now we could do two different things. We could close the line, I think. I believe we could. Yeah, let's just try that, okay? So, okay, so graphical context and then close path like this. Let's see how that works. So yeah, now it closes and we have made a T. And I could change the content of this as well. We could replace the stroke with a fill, for example, like this. That should make a, well, filled T. So let's just kill the oh, I can leave the rectangle, I guess. Now we have made a bit of a, it's a polygon basically, and this is hugely inefficient code, so why not just make it into a for loop. So we have all of this is just repeating code except for one thing, and that's the coordinates they change. So we could begin with we could make an array basically, which is coordinates, and then make one which we call or make it a two-dimensional array, I guess. So we could have the x coordinates, which is 120, 120, 85, 85, 65, 65, 30, and 30, like this. And then we could add a second array, which is the other, the y values. So 300, 320, 320 again, 400, 400, and 320, 320, and 320 again. Okay, so now we got our coordinates. Let's close that off. Always remember a semicolon, or else you might get unexpected bugs. Nobody likes that. So let's make a for loop. Basically, for loops are pretty simple, right? So you have your variable x, which, or iterator, I guess, starts at 0 and it moves throughout an array. So iterator, and we'll make it less than, or it has to be less than and equal to the length of coordinates and length of the array, like this, and then iterator basically. Then we have to put a code block here and start looping through it. So we'll use line 2, and I'll make it a bit readable, I guess. So var x is the same as coordinates 0 for the first row, and then we put iterator in the second box, which will make it, or the second bracket, sorry, and that will move through each column in that row. And save that, and then var y coordinates, and this one should have the second row, so 1, computer logic for you, iterator, and this should go through all the y coordinates. And then we can simply write graphical context again and put line 2 like this, and put x and y in it. So hopefully this should be like intuitive, but we'll see. But this means that I could just comment out this text like this, and now it's inactive, and we should only have the iterator active. So why don't we go ahead and try that? And everything disappears. So typical. So this indicates that there's some sort of bug going on, so I might have missed something, which is so typical for me to do, and we have to go through the console a bit. So let's bring up our console, because that's probably where the stuff is happening. What is content? Yeah, uncaught error at line 22. And page loaded is not defined for some reason, so that's probably because the script is buggy. 22. Where is unexpected identifier on line 22? Oh yeah, sorry, that's my retarded Java thinking creeping in. So yeah, let's try that again. And there we go. Okay, so I'll just push this and we can move on to more stuff. I'll save this and bring up my source tree. I'm putting all this into a repo. I might make this public later. I should make it public, really. I'll have a look into that. Okay, so let's just stage our changes. Commit and type in a meaningful comment in a commit, because that's good culture, I guess. So let's say we put in graphical context. We added which we used to draw a rectangle and a T shape, both of which are filled with the color. Oh my god, my typing today. Black. Like this. Okay. Also, we made an iterator. Or, well, we used a for loop, actually. We used a for loop to draw the T. Okay. Commit. And push, because reasons. Normally, when working in other projects, I would probably make a bunch of commits and possibly push them later, but since it's just me in this project, we'll just stick to this. Okay. Then we can mercilessly just kill code, and I love doing that. Just kill it, remove it. So brutal. So brutal. So yeah, I'm paying attention to the chat as well, and that makes me distracted. So let's move on to something else. We have a polygon shape, so let's use that a bit, I guess. We can also draw arcs, actually, and let's just do that, I think. Can we kill? Yeah, okay, so graphical context, begin path, and then let's say move it a bit further away from the T, but not by much, so let's say 100, and we should put it somewhere in the same space, so 300, I guess. Actually, what am I doing? We're not supposed to do this. We're not supposed to put arguments in begin path, but we're supposed to move to, and then give that coordinates. Okay. Following that, let's just quickly consult this document. Let's see. This is not advancing as fast as I might have hoped. Let's, let's deal with that later. So, we'll draw an arc, and I think I'll just shove it in some arguments, I guess. And we do that by typing graphical context again, and arc. So, I'm not completely familiar with the argument row here, so I'll just shove it in some numbers from the example I got here, like this, and then math.pi. This should just generate the number pi, and then true. So I believe the last argument is actually just the direction it's supposed to take. And then we probably want to stroke this, so stroke and finish. Let's have a look. Oh yeah, there we go. So yeah. Exactly why it ended up there, I'm not sure, but why don't we just hide our T just to see how that looks like, and save that. Actually, we could just, kill the entire T like this to keep our code simple and clean. And there we go. We see that it draws a line from the origin point, which I guess is this point here, and then it starts drawing the angle anti-clockwise. Yeah. So we can also increase radius, or say, let's try the test out the thought I had about this being the one that shows the direction. So yeah, pretty much. It changed the way it started drawing. So now it's drawing clockwise as long as you have false as the last argument here. So we can also, I think I could just change this to 90 and it will just go half the way, or it would go all the way apparently. So yeah, oh yeah, of course. Let's try something else there. Let's say 270. And nothing. Let's try 1. See what happens. Yeah, okay, so it's counting up towards... actually, I have no idea. Let's try to figure it out. Maybe 6. Does that make a full circle? Almost. Actually, oh yeah, it's probably based on pi, the radians, I guess. So we could probably write 2 times math.pi, and that would make a full circle. Yeah, pretty much. And I guess this is the start coordinate, I think. So probably we could I guess this is the xy where the base point is. So I'm wondering what we do to just move, not draw that line, I guess. We could just try to kill this, for example. See what happens. Yeah, that removes the odd line there. Okay, so we could exploit this expression here a bit. We can capture the this in another parenthesis, put it in like that, and then say divide by 4 to get 90 degrees, I guess. Let's see what happens. Yeah. And let's make more of a mess out of this. So let's grab that part again. And another parenthesis like that, and then we can say how many times we want it to move. So this would be 270, I think. Yeah, pretty much. Then we can say 4, and then we'll make a full circle again. But this is a bit of a well, we could make a method as well, just to hide this bit of reasoning here. We could just make a second function. So outside our script, I think it will basically work with create a pi, I guess we'll call it, and it will take the number of slices and or let's say total slices like this and number of slices like that. And we will expand this. So this should return a number, and we'll have this here. Like this, and it should return this. But we'll want to make some changes to this as well. So we can do that by just copying this here like this. Why did I write ranges? Like this. So we'll change this with total slices like that and number of slices here. And just finish off that line. Save, and this now needs to have a function called, so create a pie. Let's say 3 slices total, and we'll have 2 slices actual. Hopefully this should make something of a circle. Yeah, so this should be around 2/3, right? Looks like it. Yeah, and we can also increase the radius of this by just changing this number. And we can increase this to 80 to just double the size of the circle, like this. What does this one do though? I think it just indicates where you start. So if we offset this by 40, for example, it will probably go bananas. Yeah. I think this is the let's just use 2 times pi, like this. See what happens. Yeah, so it sets off at the basic point. What if we just use this one then? That should be the opposite point, I guess. Yeah. And then it continues to draw until it reaches the satisfying point. So I guess this is just like it has a reference point which is over here somewhere, and then it just draws from there, or it just sorry, words. It will begin drawing from one point which we define here with the first number, and then the second number is where it will end. But it will always start counting from the reference point, which will be the, I guess, the rightmost point in the circle, and we can determine direction. So this will probably make the opposite, or mirror it, or yeah, this will make the opposite model. And then we could just copy this and set this to false, and that will probably make a complete circle like this. Cool. So I'll kill this code and we can make a commit again. Good old source tree. Probably not so old, but whatever. Commit. We played around with the arc method. Yeah, let's keep it at that. And push. Okay, neighbors are being weird again. Okay, so let's kill this circle code and move on to some. Okay, so we covered arcs and polygons to a certain degree, and I believe actually we can just kill the create a pie as well, because we probably won't use that again. Save. Updating should remove the circle. This is, by the way, just for clarity's sake, this is all in one function written, and it is called whenever the page itself loads, using the body here and the attribute onLoad, which should call some methods, and I'm just calling page loaded here, which then calls this method here. So that's just an FYI. You could probably do it in a different way if you want, but now I picked this one and I'm gonna stick to it. God damn it. Sorry for swearing. Let's draw some text. So you can also just draw text. Let's have an example string here, okay? So let's have some random text here. Have some text here. Not so random, I guess, but whatever. We have an example string. Save. And then we can use graphical context to stroke this, for example. For those who haven't figured it out, stroke is basically just the outline, while fill is just filling the entire content of the polygons or shape. So let's use our example string and put it down at the bottom again, I guess. So 80 and 300. This should put us some reasonable distance below the rectangle up at the top there. And here we go. Let's try to see if it works. Nothing. Did I miss something? Yeah, probably. Reading. I guess maybe it's in white or something. Oh, I just wrote stroke. What am I doing? Sorry. Stroke. Text. Helps to use the correct methods, doesn't it? There we go. So we have some text here. We can also increase the size of this text. So font equal. Oh, sorry. Graphical context dot font equals, and then let's up the size a bit. So 18 points like this, and we can also set the font type. So Arial, I guess, and the line, and update, and nothing happens. Let's try upping the size a bit more. So maybe that was the default, who knows. Let's try 24. That should increase the size. And nothing happens. So let's have a look and see if the console is acting up. Nothing. So I'm missing something apparently. Let's just try running these side by side, and this one should be 40, so it's a bit further down. And let's put this at 10. This should be some random text. So am I missing something? I did write the correct method this time, but it's not changing the font. So what have I done? Is it stupid? Maybe it's a stupid thing like just quotation marks. Like this. Let's try. No effect. I guess I'll just revert this to the previous one, like this. Just nothing happens. Huh. That is a bit weird. Let me have a look. HTML5 canvas reference. text. Maybe is it something as simple as this? I hope not. Oh, there we go. Okay. Update. So apparently it was just the way it read it, I guess. Yeah. Okay, so we have text. Hurrah! I guess we could also, just a quick demonstration, we can also change the color. So I'll change the fill style like this, and we can set that to red, end of line, and update, and nothing happens because typical, I guess. Did I write something wrong, or no? This is not for text, I guess. I guess actually maybe I could I just write red like this and kill this line because we don't want it, or it doesn't work. Some random text here, and it changed the font probably because well, what if we just write color red like this? No. Nip. Nada. Okay, so how do we change? Let's look at the documentation again. Font style. Could we just change the maybe stroke style works since this is a stroke? Graphical context strokes. No, not text strokes. And then just change it to red. And probably end the line as well. And update. Yeah, so this is the fun bit. Once you make a change to the graphical context, it should. I think I'll just demonstrate it first and just show what happens. Save and copy paste, or cut and paste. Now it's after the first text, right? So save and update. So as you can see, now the topmost text is black, but the one at the bottom is red. And this is due to the changes you make in the graphical context settings. So when you do that, when you make a change somewhere like this, the change sticks, and it will maintain the red color in its stroke style. And this will probably be true for let's make a rectangle, right? So graphical context, stroke, rectangle, I think it's called stroke rect, yeah. And let's put it a bit below the other rectangle, so 200, and instead of 10 we'll just make it 110, and this one will be 100 and 100 in dimensions as well, and that line. So as you can see, we get a small box here, which is, hang on, let's move this a bit, 120, just to move it a bit further down. So the box here is also red because the change in color is sticking it's stuck with the context, so it will remain that way. But we can also just make a change whenever we feel like it, like this, and say move this one, change this one to blue. And as you notice now, the text also changes color. I hope it's visible, by the way, because my icon is not, well, my thumbnail is not so great. The changing color sticks, and it also moves on to the rectangle. So this is the graphical context just changing or storing whatever you feed it with options. We could also make this black here again and restore it to the default value, and we will have black text and a black rectangle as well. We can also change the fill style. Let's just do it before the filled rectangle. Graphical context dot fill style, like this, and it's not a method, so we'll just, this is a, if I'm not mistaken, this is just a field in the graphical context object, so it probably won't need a method call, or it probably can't accept it. Let's just change this to blue and update, and we'll get a blue rectangle instead. So yeah, now we have some basic graphic stuff up. I'll just again save and push. Let's commit this. Demonstrated use of text and styles. So there's a whole, you could okay, before making this commit, let's just wait a bit. Let's just wait a bit. Let's go back here, and I'll try to show something else as well. So I'm using W3 Schools as well, which is a great resource. I recommend it for anyone who wants to use web development. It looks like this, and at the bottom of this page there's a color picker, right? And it has a big palette. It has all the colors you could ever desire, except for ones that don't exist, whichever they are. And you have several kinds of methods of getting these colors in different descriptions. And a very common one is to use these here hex codes. I believe they're hex codes. Correct me if I'm wrong somehow. And we can also use these in the fill style wherever we request colors, and we can update it, and as you can see it turns green as we picked from the color picker. And yeah, just this is the URL w3schools and .com. Then you can navigate your way, or you can just write /colors/color picker or /colors_picker.asp, and you'll find this site. Okay, so that's that. We'll make the commit now. Stage all and commit. Hopefully, yeah, this should also have the changes for the hex code. So this is by the way Git technology. If you're not familiar with it, I recommend reading up on it. It's a great way to store your code, and also to work collaboratively with people. One of the advantages is that when you make changes to files, it will show exactly which lines are changed and what new content you add to it. So it will show what is deleted and so on, and it allows you to basically look where people are working when you're dealing with a larger project group. But for now we're just, it's just me working on this, so this will probably be a lot of commits by me in a very sad and lonely repo, but who cares? Okay, so we've now we've now we have so far we have used arcs. We've drawn some lines. We've drawn some basic shapes. There are a couple more shapes, and I encourage you to check them out. There's a lot of, if I'm not mistaken, at least. Yeah, I think actually from the reference here on W3 Schools, you have rectangles, which, because rectangles are so great, and then you have paths, which is used mostly to make all the other shapes, or you can use it to make all the other shapes with those basic kind of basic methods. So you can make very like you can make hexagons, for example. I can make an example of that later, by the way, if people want to see that. Or you can draw like clouds, I guess. As long as you have the coordinates for it, you can draw arcs and whatever, and it will look great, probably. Unless you suck at coding, I don't know. Okay, so we made these things, but now let's try to load in an image. Because images are the bread and butter of games, right? You want to have animated graphics and so on. You want sprite sheets and whatever, and I'm gonna try to tackle all of that as we move on. So let's just start with loading in a simple image. So we'll kill this code here, and we can leave the rectangle, I guess, because I kind of like it. It will be the landmark of this project, this blue rectangle. At some point we're gonna sacrifice it on the altar of progress, and it will be a very emotional moment, but not this day. Not this day. We're gonna have that rectangle for now. So I'm just gonna have a quick look at the chat, and there's progress here. People are actually talking. Mostly friends who think I'm sad, I guess. No? Let's find an image. So I'm gonna get my reference up here. It pops up in the screen. Embarrassing. Let's have okay, so there is this site called pexels.com for all you people who like stock images. Looks like this. Basically, it allows you to just pick stock pictures for free, and they have a lot. Apparently, yeah, Creative Commons 0 is the license, so this means the pictures are free, completely free to be used for any legal purpose. So you can use it commercially if you want. I'm not monetizing this stream or anything like that, so this isn't for any other purpose than education. Okay, let's find ourselves. See, I've been searching for this a bit, and let's find something serene. Let's see if that shows something. Oh yes, this is so serene. And this is a picture with horses. Let's use this. So this was uploaded by Brian, some guy on Pexels. I'm just gonna click on it, and I think we can use this URL here, but as soon as it's loaded in, we'll also save it. Save it image as, and put it in the correct folder, pictures, saved pictures, and let's just rename it to horses to have a simple URI to go for, like this. Okay, let's kill this mercilessly. Don't grow tabs, by the way. You don't want a lot of tabs. Okay, so now we're gonna load in images. And by the way, as I mentioned earlier, I'm using the Pro HTML5 games book, and I'm just working my way through the chapter by chapter basis, and I haven't read it a lot in advance. I read it a couple of times, like way back, but I don't remember anything almost. I just remember broadly what the content is, but not exactly how to do things, and especially not the syntax. So, yeah, bear with me, please. So, what we can do is that we can move the saved image. Saved pictures. So this is my Explorer folder here. We'll just make a copy, and then we'll move on to the documents, coding. Sorry about the mess here. And we'll save it in the same directory as our index file, like this. Kill it, and then we can just load in the image, like, oh, what am I doing? We can load it in like this, and then just write horses dot was it JPEG or PNG? Why did I close this too fast? Okay, frequent. For some reason it didn't want to show there, so we'll have to navigate our way again. So it's a JPEG, so, and that's the file extension, not JPG. So by saving this, we should probably get images of a horse down below, and this is a huge image, so yeah. Let's just comment this one out. But now at least we have the stem of a URI here, and we can upload. We can reload this. Okay, so now we want to load this in, right? And there's a couple of strategies for this, and yeah, we can load it in. Actually, it was probably a bad idea to comment this out. We'll leave it back in again. And we'll give it an ID, which is horses, like this. And we'll save. And now this one will be visible again. And it's not what we want, but whatever. Now we'll continue here. We can get our image, right, using the DOM, using our document properties, right? And that is just using document.get element by ID, and we'll just call it, say, horses, like this, and that should probably get our image. And then we can use our graphical context to draw an image, and then image, and then we can specify the location. So let's say 2020, because hindsight, you know, and this should show up in the, or it, yeah, there we go. So now it draws it twice. Actually, we can probably if I'm not mistaken, we can probably change the height. Say 20, not 2000, and okay, width and height. Never height and width. 20 like this. So yeah, now it's really compressed over here and not compressed over here. Interesting, right? But that's basically because the element itself is scaled, but the file is not. And I think the draw image just fetches the resource itself without actually accounting for the specifications of width and height in the image tag. Yeah, I believe we can also scale it here, at least according to the text here. So, well, let's see what happens if we do this. So now we have mangled the picture a bit. It's not supposed to be this size. This is a rectangle. This is a square, right? So that's not what we're. Maybe we want to preserve the ratio, right? So let's find our image again and get its properties, details. So the dimensions of this image is 4,396 times 2,767, and we can actually do something about that. We can scale it properly by just getting those dimensions. So var height first, or width. What am I doing? I broke my own rule immediately. Let's just let's say we want to scale it down to 90%, 10% of its original size. So we can just take the width, which is 4,396, so like this, and then divide it by 10. That should put it down to 10%, right? That's actually still a bit huge for our purposes. So maybe 5%, so 20. And var height is supposed to be 2,767 divided by 20. And then we can just replace these, I believe. Height and... oh, what am I doing? Again! I broke my rule! It's supposed to be width, like this. And height, like that. Okay, let's see how that works out. And there we go. It's now proportionate, but scaled down. So, as you might notice, this takes a bit to load in, and that's something of note. I think the program will work much faster without these huge images. So what we could do is to make a scaled down version of the same image and see if that loads faster. And a basic way to do that, a simple way to do it, is just open the picture in Paint. And I'll show you how. I assume you can open images in Paint. If not, then reconsider your life choices. Okay, here we go. Images in Paint, and we can then resize it. We'll get this. Let's say we'll want to have it at 20% of its original size. The aspect ratio is the same, so hit OK. It's now reduced to more manageable sizes, right? This should be in pixels, yeah, around 800, so maybe half of that again. Like that. Okay, so our expectation is around that it should fit nicely within the canvas. Let's just save it, and that should and we can kill these bits here, because now this shouldn't have a huge of an impact on the HTML itself. And now it loads much faster. And yeah, notice that this didn't really change anything, because what we're dealing with here is just the aspect ratio, and this is just a number that's like essentially separate from the actual image. I just read it up from the details, right? So this will provide a size or a proportion which will still work, even if the original image is not of that resolution anymore. And actually we could scale it up to ridiculous amounts and probably get a very pixelated image. But now I just remove the divided by 20, right? So saving that should make a very huge image. But I believe due to the original image not being particularly huge anymore, that won't severely affect the load times anymore either. Sorry, chat is a bit active here. Yeah, okay, so we loaded an image, right? That's great. Let's just kill. Actually, we could just make it like. Actually, let's just leave it. But we can change it to the original resolution, so and original height. Actually, not original, but oh yeah. So like this. Let's kill these. And now we can that was not what we wanted, I guess. We can figure out the actual resolution again. I should have been able to remember that, but okay, maybe I didn't. Or I wasn't actually interested in remembering, so let's just fetch it. You should be able to right click on an image file and just go on to details and be able to read its dimensions. So 440 and 277, like this. And that should reload it in its original, or not original, but actual size. So it should be the same now as the element itself. Okay. And just a quick look at the image. I'm just wondering if it's possible to just hide the actual SRC or not. I mean, we probably don't have to hide the image element because we could probably load it in with an async method. But currently I don't know the syntax for that, so at least not yet. We'll figure it out, but Let's head over to, I'm at the W Free Schools site again, and you'll probably see me go there a lot, because it's so useful. So I guess there's no we could probably use CSS, I think. Let's see. Okay, so it has image filters. Then we should probably be able to do something about it. CSS reference. Okay, so let's see what happens if we write display none and the line as well. Hooray, it disappears. So yeah, there's that. Okay. Moving on. This is the yeah, okay, so I messed up my streaming settings, I guess. Key image frequency. I guess I have to figure out that later. Let's has the image frozen? Hope not. Ah, there we go. It updates. This is probably taking a toll on my computer as well, so I'm sorry about crappy stream quality. I'll try to do something about it over time. I'll switch this one. Okay, so we've loaded an image, and we can do some stuff with it. Actually, we can. So this will be the meat of the whole thing. About, well, we're going to use images, so we want to move these images, right? And we can do this by using translate. So we have an image. So let's say graphical context dot translate, and then put it in a different position. So let's say 30-30. It's a very modest move, but we should be able to notice. Okay, let's have a bit more than that. X to 100, let's say. That should move it a bit. And no change. So I missed something, I guess. Yeah, translate, I believe, doesn't actually move the image itself, but the reference for which everything is drawn. So if we put this here, maybe it will have some changes. Yeah. So this it moves the origin location of the object itself. So let's try to show how that works. So let's have a line. Let's just graphical context begin path like this, and let's start it at 0, x0, and then at 50, let's say. Okay. And then just graphical context at line 2 like this, and then move it to then I guess 20, 50 like this. That should put it to where the image would not actually where it would start, but around the same x location as the image itself started, but not the same y location. Okay, so graphical context dot stroke, and that should probably draw a line, and it didn't because I probably forgot something. Yeah, close path, I guess. So. And again, nothing. What am I doing wrong? We should be able to see it, but it's not showing up. Why? Am I missing something? Oh yeah, the move to part. I mess up. Move to, and then 0, 50, and then let's just remove those arguments because they probably shouldn't be there. And there we got our line. Okay. And let's just set the okay, so we'll comment out the translation like this. That should put our image back to this location. So the black line represents where the origin draws to the image area, right? So actually we could just say we move it to 0 like this, and then 2020 like this, and reload, and we'll get, this is the line from origin to where the image starts drawing, right? Okay, so we'll have that color in black, and then we'll set the graphical context stroke style to red to signify the change in change in translation. But let's just see if close path works without the yeah, it works. So we don't need to have close path. And okay, so we changed the stroke style to red, so that then we'll make a new line, and we will move that one. We'll just copy paste this and use it again, and then we'll set these to 20, and this one should be then to where the translation point is. And let's just for the moment not show our image, just to show the change. Okay? And I believe this is correct, right? We move the origin to x 100 and then down by 30. So let's just put back the image, and it shows like this, right? And then remember that the translation of the origin point is after we've drawn our lines, so but before the image. So when we update this, the image should move to the end of the red line, and it doesn't. Oh yeah, of course, because we have we added some extra info. So let's just adjust this to 40 and this to 120, not 1200, but still off by a bit. Why is that? Because the change was a bit further than that. So there we go. So this is a simple illustration of how it works with the move of origin. So this black line is where is kind of the position where it would expect to show up without our translation, but due to the translation it will now show up here with the same information. And the actual origin point, let's just draw that as well. And we can change this one to green just to have a different color. So the red one goes to the location where we expect the image to show up, but let's show where the translation point is as well. So we'll not move this to 2020. We'll move this to 0 to origin, but before the translation, and change this to the translation coordinates. And by an update, we should now have the original origin to the new origin point. And we can also show, since we have the 2020 from origin translation, we can also show that by copying our line again, then changing it to red just to display the change again. Let's move this to 100 and 30 like this, and we want this to be 120 and this to be 50, I believe. And this shows the translation post translation. So this is some basic things about using translations. So you just change the origin point of where images are drawn, basically. Yeah, I'm not sure if you can actually move images after you've called the context on them, but you can represent them as an object, for example, and then update those informations and just call just make it redraw itself. I'm not entirely sure if that is the way generally it is done, but I believe that is I think that is how it's done, at least, because that would be close to what you do in Java with Swing, for example. Okay, so let's try something different. We'll kill all these actually, we can just make a push right now just to save this. Make a push, or make a commit at least. Loaded in an image. moved it using translate, added paths to display where the origin point moves after using translate. All lines are drawn before the translate method is called. Yeah, I think that is an okay commit message. Push. Okay, so now we have that piece of code saved, and we can now be merciless and just kill all these lines. It's brutal, but we're doing it. Like this. And we still have this compressed code and small space to work with, just a few dozens of lines. And now we made some changes and it will account for these, so it noticed that we killed all the lines here. Okay, so let's save, and this should just remove the lines. Okay, so instead of translate, let's just try rotating, because that's something you can do as well. So rotate and math.py like this, and that puts the image squarely out of view, but we can do something about that. Let's multiply this by, not multiply it, but divide it by 20, let's say, like this. And as you can see, now we have the image slightly in view, because the point it moves to is rotated a bit. We can actually, I can see if we can make a demonstration of how this actually works, and we can use the arc to display how that works. So this is before rotation, right? And we can make a point first, I think. Yeah, graphical context, begin path, and graphical context dot move to 2020 like this, and graphical context line to 2020 like this, and graphical context stroke. That should put an image or a point, shouldn't it? Let's just, does that show up? Yeah, okay, so now we got a small point there. I hope it's probably not so easy to see. Yeah, well, whatever. Deal with it. Graphical context, begin path. You can actually just move the image position a bit out. So let's say 40. Just making all the corrections here. This is a bit slow way of doing it. I could have used Sublime's multiple mark locations. Let's not push Irania's code, at least. Okay, so now we moved the image a bit out. Actually, let's just demonstrate how Sublime works in that way. And I messed it up already. Again, let's try over. Let's change this to 80. Powerful move, right? Okay, so now we pushed it a bit out into this field of the canvas, right? And we can draw an arc from that point, I believe. And yeah, let's do that. So the center of our arc should be that should be around origin. So let's just see if we can let's see if we can just so it's known, I'm terrible at math, by the way, or at least geometry, but we'll get to that in time. We want our origin of the arc to be at 0. So 0, 0. And the radius for simplicity's sake, let's just make this one 0 so that we can let's not do that. Like this. And this one should be 1. And an update should... Oh yeah, erroneous code again. Sorry. Again. Actually, just comment that out. That should... Okay, so now we have our dot over at this location. And there's a slight rotation, right? And then we can start up our arc again, and now the radius should be 80. Like this. And we want to show how much we're actually moving it. So we can say, we can make a variable, call it radians, and we'll just take that, copy paste it out, and put it in here instead. And then we can just write radians here, and 0 radians. No, radians, like that. And we should put this counterclockwise, or clockwise, I mean. And we want to stroke this. So graphical context.stroke, like this. Then we should probably get, yeah, now we have this small line here, right? So let's do some more just to show how get a more visible example. So radius equals 150, and then we'll say that this is radius plus 1, and this now becomes all the image position should be actually this. Every reference to 80 should be radius, like this. This should push it a bit further out. And oh, holy shit, sorry. I'll have to pop away a bit. Alright, I'm back, and before I suddenly jumped away, we had this artifact showing up here, a line, which I have an idea why it shows up, and it is probably just due to me not closing a path, and we can do that. Oh yeah, I think it's just because I have mismatched these. I switched these up, so this should be like this, I think, and it disappears, I believe. And we can also just, I don't know if we're supposed to do this, but it begins a new path, so I think it should end the path, the one point we have. Well, so yeah. Now the artifact is gone, at least, so that should be good. But now we can change the radiance a bit and get a much more of a rotation. So we could, for example, we could lessen these this division to actually we could call this, where do we have radiance references like this? So radiance base and bar actual radiance like this, and that would be radiance base multiplied by any number between 0 to 20. So let's multiply it by 5, and that should move it a bit further along, and then we can just take radiance base and replace it with actual radiance like this, and that should move it a bit. Ooh, that moved it very far, more than expected. So what is going on? Let's have a look again. So we have math.pi divided by 20 here, and we multiplied it by 5. So what is this though? Why is that line showing up like that? Let's have a look. Let's just make sure that we know what we're actually dealing with. Is it that line block? Yes. So control set. Did we do something about the rate? Yeah, this one. Yeah, of course. This should just be 1, not just radius plus 1, because that would put it at 151 and in y direction, and that would be, of course, way into the actual space, the canvas space. So that's not what we want. Now we have this line here. Actually, we can just increase this to 10, like this, and we should have our a bit of an indicator here. And let's have a look at our arc here. This one, it seems to be, I think it's drawing, but I think it's maybe drawing in the wrong direction, or at least not the one I want. So let's move the graphical context by a bit. Our radius is still the same, so it shouldn't be much. Let's just move the context itself, or the origin point of the context to 80, and see what it draws. So it doesn't show up at all. Let's try 150. Nothing. Not even our arc is showing up, and that is a bit confusing. So maybe if we restored this, are we getting an error? Just gotta check. Yeah, radiance is not defined. What happened? Of course, we have a radiance, but it's not defined. So we should put this to base. Is there any more? No. Okay, so that was messing up with us. I didn't catch an error. So let's try it again. So there we go. Here we have the image again. Now we can probably increase the actual radiance a bit, and apparently nothing happens. Still nothing happens. So what's going on? Oh yeah, our actual radiance. This is the radiance base, but we want to show actual radiance. So like this. And that should move it a bit more. And this should now also be actual radiance to actually draw the full arc, and then we have our arc following the origin point of the image, which should be this is like the origin plus radius, so 150, and then accounting for the rotation of the origin point. So hopefully this illustrates a bit how the rotation part works. We could replace this with rotation number, I guess, and just define that in advance. So var rotation number equals, say, 4, because we want to increase it to 4, and then we'll get even more of a rotation. We can say 5 and 6, and it moves even further. So let's just put it back to 3 so that we have it mostly in image. And yeah, this is a bit of stuff to show rotation. And this is as good as time as any to make a commit. We have toyed around with rotation of the graphical context and showed briefly how it works with an image and an arc line. Just to be on the safe side, maybe let's bring up our V3 school here, and actually let's just find the canvas reference. HTML canvas. So this one explains stuff in with use of JavaScript. So we probably want our canvas reference. HTML canvas, and transformations. Let's see if rotate has any more arguments. No, it just takes angle. So then it would be an interesting point to see if we could make it rotate the inverse or counterclockwise, right? So did I make... I'll just make this commit and we'll have a quick look. Pop that back down. Okay, so we can always just change the radians to be negative, but we'll want to do it here and not ahead of this this arc drawing here, because that would actually, yeah, we want to do that. Never mind. So let's change it here to radians base equals minus radians base, like this. I believe that should make it negative, negative number, right? So update, save, update. Okay, so no change. Maybe we want to console log that number just to see. Actually, we could just skip the whole console logging bit, and we could have at the bottom fill text. So graphical context, or maybe before the rotation so that it won't be rotated as well, and fill our stroke text and radians base, and we'll put that in the opposite corner. So the width of our yeah, let's make it 500 and approximately 40 down, like that. Let's see if, yeah, so that's the number we're feeding it. And it's not handling it. I guess that's not, maybe we get an error as well, just could be interesting to see. Nothing, but it's not making a change at all. So if it only accepts a positive number, maybe, or I don't know, maybe it doesn't. We could actually just try to write radians space like this and comment out this. And see what happens. Oops. A bit of a quick on hotkey here. Did I freeze Chrome? No, there we go. Just making a slight change to check something. It looks like yeah, of course. I'm an idiot because I was changing radian space, but not actual radians. So, okay, let's try that again. Stroke text should reflect. Okay. This should be actual radians, like this. Let's see what happens. And there we go. Maybe we want to change this to 0, so we don't get that line. And now our image has rotated upwards, but the arc itself has taken the time to draw a full loop. I think we could actually just switch this to true, and that loop shouldn't show. Yeah, so now we only got the artifact from the point where the rotation should begin from. Let me just have a look here. Yeah. Okay, so we have rotated our image, and we're now gonna I guess do something else. We've covered rotation, so maybe actually I'll just push this just to have that in memory as well. Toyed with rotating counter. Come on. And we'll stage the index file again. Like that. Now we have that also in memory. Let's kill this, and now we'll just remove everything that looks like image references, or everything that has anything to do with rotation. So we should be back to oh, for some reason it killed the image as well. Yeah, that was not what I wanted to do. Did I kill a bit of excessive code? Let's have a look at our Git. Oh yeah, I killed the references to where it was positioned, so this should be 0 because we have no reference to radius anymore, and I forgot to remove all references to it. So here we go, image is back again. Okay, we can leave that for now and have a bit of a look in the book again. We can also use scale as a global thing. I'm not exactly sure how that works, but we'll have a look at that as well. It accepts X and Y, so 2, 2. This will probably double the image, but we have to make sure that we have proper syntax. Yep, increases image if we put 0.8. This should probably shrink the image. a bit. Yeah, yeah, pretty much. And yeah, that's scale. Useful for zoom. If you want to do something like RTS, then you might want to add zoom, and then scaling is one of those things, basically. Yeah. Let's just commit this as well. Saving the HTML site is useful. Commit and use the scale method in the graphical graphile context to shrink the image by 20%. Commit and push. So you might ask yourself, why on earth am I showing you this? I'm actually just showing you a bit of workflow. This is a bit of my workflow, and I think it's useful for like documenting the changes in your code over time and allowing yourself to be able to go back and change something, or have a look at like major changes in your code and possibly use that to debug, or maybe even find a viable point to roll back to. Think of it as like playing a computer game where autosave is disabled and all your progress is saved whenever you make a commit, or when you go to save the game, right? So if you forget yourself and play for hours, and for some reason you get killed or whatever in the game, then it would suck to have to replay 4 hours or something because you didn't save your game frequently. And that's kind of the deal, and that's why I do it. That's why I commit often. So whenever I change kind of topic or something, I make a commit change. So yeah, that's what I'm about. That's why I do this. Okay, so we have drawn polygons, we've filled some rectangles, we scaled images, we rotated the whole image context or graphical context. We also translated the graphical context, and translate is an important method as well because we're going to use it for parallax effects, for basically having scrolling effects in the game. So yeah, that's important. Yeah, we can also load in audio, but I don't really have anything. I don't really have anything at the ready just now, I think. So I'll get back to sounds later. I don't have any. I don't feel comfortable adding sounds just yet. I promise I'll get back to it, but for now, let's stick with images and graphics. And yeah. So yeah, let's do a small change. To our code, because right now we're fetching the image from img tag here in our body, and we're hiding it such that it doesn't show up. But there is another way of doing it as well, and that is by taking this route. We can kill this reference here like this, and call a constructor called new image, and this will make the object or variable image will make it into an image object. And then we can say image.src equals and then horses.jpg, and then I forgot that we actually need to capture this in a string like this. And I believe this change should produce no visible result in our canvas. And yeah, pretty much no difference. So what we can also do then, I believe, is just to kill this line here with the image tag, and then we got a change actually. Did not expect. Is that because it is not loaded, or yeah, it's probably because it's not loaded. So, and I believe I know why this is happening, and that's because we have an asynchronous method being used here, or that's what's happening, I believe, at least. So we could prove this pretty simply by saying that, or it's probably not showing simply because we called page loaded and it didn't get the image in time, and then when the method itself, the assignment of the image was done, it's already too late, so it didn't show up. Okay, so we can make an image loader. And we can make a small. We can make a couple of functions to deal with this. So we'll make a we'll make an object first. So var image loader equals, it's an object, so why on earth did I assign it to that? It's an image loader, so we'll have a loaded variable, field, which is set to true. We'll have loaded images set to 0. Loaded total images 0, and then load which will take load image and URL, and then we will have to define our load image, which we'll call function load image URL. And we'll deal with the body like this. In that area, we'll actually screw that. We'll make it in. We'll nest it anyway. I could probably expand it, but my brain is not up to snuff right now. So let's just use the example I'm following: total images ++, because now we're loading an image, right? So this loaded equals false, because now we're starting to load an image, and when we're doing that we have to set this variable to false. So image src equals URL, and image on load, like like this, should be function image loader loaded images plus plus, and if image loader dot loaded if that equals loaded images, then we can do the following. Image loader loaded equals true, because then it has loaded all the images. And right here you can say return true, or image, sorry, like this. Okay. Okay, so we have our image loader. Let's move this further up above the function. I think object precedence is active. I don't know if it hoists those as well, so I don't want to risk it, but we can try loading the image now. So instead of new image, we can just oh, did I? No, I didn't do this correctly. I forgot a small thing here. We need to have image bar image new image like this, and that should complete our reference. And I have not bought Sublime. I'm sorry, whoever made Sublime, I haven't bought it yet. And what we can do then is to load it. That should be pretty simple here, I believe. We use image loader, load image, right? And then just feed it this string here. And then save. And then we probably have to wait until it loads in the image. Let's just check if the console reports an error. Yep, line 12. Let's just look at the console first. Unexpected. Okay, because this is a function. this. And 57, is that a bug as well? I think that problem should disappear by now. Still no image. I believe we're still dealing a bit with callback. Just I have to be sure that I'm not missing something. Have I wrote the URL correctly? Let's just have a look at the log first though. Load image is not a function. Well, oh, what if I just put load like this? I believe we can just anonymize this and this will still work. But our console will probably say okay, so this has happened and it has returned. This should probably have no effect on the image itself. Yeah, I'm pretty sure this is that this is our callback bug. So it probably means that I should nest something. We could probably try just handing it graphical context. So like that, and you could copy paste this here like that. Instead of returning image, we could simply use this bit here to put it just below this line. We can kill some indentation, and we can try it again, and still nothing. Width is not defined, of course, but we can we'll just use the numbers for this time. And there we go, we got our image. So so yeah, that's a callback issue basically. And the thing is that when you have callback issues, JavaScript is kind of weird that way. When you have asynchronous methods, you will usually have this effect where you can have, well, usually when you would look at code, you will see this this part here. It will you will usually think that this line will execute before this line, and whenever you're using code that has no async methods, that will be true. But as soon as you have one, such as file loading or using external resources like for example a database or some sort of API, then you will be calling something asynchronously. And there's probably stuff like Angular which can deal with this better than the code itself can do, but a way to handle this is to just nest it. And this is, for your information, not pretty code at all, and there are ways to deal with this. And that would be just to kind of just expand the code a bit and reduce the amount of nesting, because now we're getting a lot of indentation here. But what I did, as I showed you, is to leave the graphical context in the innermost nest, because this would only happen once it is loaded. So the thing is that it will pass the template for the instruction for the functions to the to a thread or something like that, but it will not execute it immediately. It will wait until it has done whatever it needs to do. So what we can do here with the unload, for example, we can make it actually we could make that do something more, or we could make that like execute rendering, but then the whole image loader idea, it kind of breaks apart. We should probably do something about that. But the thing is that as long as you have the final call for drawing at the innermost nest, then you're good. So you can use image onload as well to do stuff as well. We could probably refactor this a bit, because we're loading our image here, right? So we can change this a bit again, like this, and we can pull out this piece of code and leave it here again. So saving this should probably result in the image not showing, right? So what we can do is to make an anonymous function, and say image on load, and then function. Actually, let's not do anything about that, but since this is inside an already existing function, we can probably just put the graphical context in here and load like that. Saved. Oh, it's not working. Oh yeah, that's because we're not returning an image anymore. We probably want to do that, so let's do that. That's a closing caption, so we want to put this here, and we'll say return image such that we actually get the image as well in return. And there we go, image back. So now we could go back. Actually, we could just say we could skip the whole image loader class, but that one is probably meant for loading a lot of images and then calling a final onload when all of the images are correctly loaded. Let's say we load several images and it will check if all the images have been loaded correctly. That's what it's doing basically. So we have several images and we're returning them. But the whole but the thing is, as long as actually we could instead of using image on load, we could change this up a bit and say if or maybe it won't work, but let's say image loader dot loaded true, like that. Let's see if that runs. No, it doesn't work. And yeah, I think we'll just have to use the image onload to deal with this. So equals function anonymous that does this, and we got our image back. But we can skip the whole horses dot. We can skip this whole thing here, and we can say new image like this, and image dot src equals horses dot jpeg and save and load again, and we got our image. So we can kill these now, and I'll leave the image loader in for this commit, for the upcoming commit now. Stage all. Commit played around with loading images in the script. Made an image loader which currently doesn't work as expected. Used image onload to deal with callback. Okay, and commit. And push. Yes. So we got our commit done, and we have now some of the basics of loading in images, and I believe we have spent about almost 3 hours doing this. Time moves fast. I believe that I'm going to call it the end there because it's getting late where I'm at, and I'll just continue this project at a later point. I'll also save my project and call it first prototype, like that. This should also show up in my commit. I don't know if this is a good idea to upload, but whatever. Stage all. Commit. First added Sublime project workspace. Like this. So I'm not experienced with working with Sublime on multiple or CSV, CV kind of style, but basically you should be able to just load in this file on your Sublime text editor and you will get the same project overview. I have an inkling of an idea that it might not work because the absolute path to the file is not the same in on someone else's computer, so I might put that to get ignored later and just have it removed. But yes, I hope you have enjoyed the show thus far, and yeah, it looks like the image is a bit frozen. Too bad about that, I guess. There we go. It's back again. It freezes up a bit, and I'm sorry about that. It's my computer. It's not the best. I hope this has been rewarding for whoever has watched it, and I'll make a new video next Friday. It will be live streamed, so all the dirty mistakes and all the interruptions of daily life will also be present. Yeah, I hope this has been worthwhile. If not, let me know. Dislike my video if you want, whichever. See you next Friday.